Hello guys, how are you today? So today I'll be solving the physics course practice from 1.1 till 1.4. So let's start. Very simply, they told us which statements about the temperature and sensation of hotness are true. Very simply, all you should know is that temperature is the degree of hotness of a body. You can know how hot, not how hot, you can know if a body is hot or cold by the temperature, okay? Now, the sensation of hotness and the sensation of coolness happen like this. When you touch something hot, the heat particles or the heat will flow into your hand. So that's how you feel a sensation of hotness. Whereas when you touch something cold, the heat will flow out of your hand. So that's why you feel a sensation of coldness. Always remember that the heat will travel from the hotter body to the colder body and never the opposite. So when we're talking about coldness, you cannot say that the cold will flow into their hands. That's wrong. You have to say that the cold flows out of their hands. Alright, so a person experiences a sensation of hotness when the heat flows into their hands. This is correct. Now, a person experiences a sensation of coldness when the heat flows into their hands. No, this is wrong. It's the opposite when the heat flows out of their hands. Now, you cannot measure the sensation of hotness. Okay, so if you touch something hot, you cannot say, oh, it's 100 degrees Celsius. No, you cannot. You can only know it's hot, it's cold, but you cannot measure it exactly. So it cannot be accurately measured and it cannot even be measured. So the only two answers for number one are these two. Now we move on to question number 2. A fixed amount of gas is sealed in a rigid container of volume 10 centimeter cubed. Initially, the gas is negative 73 degrees Celsius and 800 millimeters of mercury. In order for the pressure law to be applicable, all right, I'm going to state the 3 laws. We have pressure law, Boyle's law, and we have Charles' law. In the pressure law, the only thing that is constant are the volume and mass. In Boyle's law, the only two that are constant are the temperature and mass. In Charles' law, the only two that are constant are the pressure and mass. Now memorize these, they are important. And for the equations, very simply, just memorize this one equation. P1 times V1 over T1 is equal to P2 times V2 over T2. And then, which one is constant? You cross it out. So for example, in order for the pressure law to be applicable, okay, we go. Pressure law, the volume and the mass are constant. They're telling us which of the following quantities must remain constant. We have volume, then mass. So we don't have mass, that means we're not going to choose anything else. Now, they told us in part B, if the pressure of the gas becomes 1200 millimeters of mercury, they need the new temperature of the gas. So, temperature 1 is negative 73 degrees Celsius. Okay, and what was pressure 1? Okay, temperature 1 is negative 73 degrees Celsius, and then pressure 1 was 800 millimeters of mercury. So now we said we are gonna write the rule for all of them, which is P1 V1 over T1 is equal to P2 V2 over T2. And we said because we are applying the pressure law, then the volume is gonna remain constant. So very simply, you're gonna cross out the volume. Now you have then pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Remember, the temperature always has to be in Kelvin. It is the absolute temperature. So here, this temperature over here is wrong if we use it because it's in degrees Celsius. So to change it to Kelvin, we're just gonna add 273. So minus 73 plus 273, you are gonna get 200 Kelvin. So now you have temperature 1, which is 200 Kelvin, and pressure 1, which is 800 millimeters of mercury. So substitute 800 over 200 is equal to, they gave us the new pressure. So pressure 2 is now 1200 over temperature 2 that we need to find. So solving it, you are gonna get that temperature 2 is equal to 1200 times 200 over 800. And if you do it on your calculator, you are gonna get 300. So now we have what we have, that temperature 2 is 300 Kelvin. Now, do we need it in Kelvin or in degrees Celsius? We need it in degrees Celsius. So to change it to degrees Celsius, we are gonna subtract 273. So 300 minus 273, you are gonna get 27. So our new temperature in degrees Celsius is 27 degrees Celsius. Now we move on to question number 3. We need to identify thermometric and non-thermometric properties of objects. Remember, thermometric properties are properties that change with a change in temperature. So as long as you change the temperature and it stays changing, then it is a thermometric property. Let's start. Volume of a fixed amount of gas at a constant pressure. If you heat it up, you have a constant pressure first of all, okay? This means what? This is Charles' law. Okay, Charles' law states that the volume is directly proportional to the absolute temperature. So as you as you increase the temperature, the volume is gonna increase. As you decrease the temperature, the volume is gonna decrease. So this is a thermometric property. Why? Because it changes as the temperature changes. Now, mass of a fixed amount of gas at a constant pressure. The mass should always remain constant, no matter what. The mass at the beginning of the reaction has to be equal to the mass at the end of a reaction. So it's not changing with a change of temperature. So we say it's a non-thermometric property. Hardness of an egg. This one is a bit confusing. Why? Because as you heat an egg, it changes from the liquid form into a hard solid. But then when you cool it down, does it return to a liquid? Definitely not. So the hardness of an egg is a non-thermometric property, because even if you increase and it changes, if you then after increasing decrease the temperature, it's not gonna change back. Now the length of mercury in a tube. The length of mercury, as you increase the temperature, it's gonna increase, but as you decrease the temperature, it's also gonna decrease. So it is a thermometric property. Now we move on to question number 4. Okay, this one is nice. The equation we need to know for this one is that the average speed is directly proportional to the radical of the temperature. So let me put alpha instead. The average speed is directly proportional to the radical of the temperature, meaning we can write it in this form of equation: speed 1 over speed 2 is equal to radical temperature 1 over temperature 2. Of course, temperature has to be an absolute value. We start with temperature 1, which is 300, over temperature 2, which is 1200, and then we don't forget the radical, is equal to speed 1, which is 1900 meters per second, over speed 2, which we need to find. Very simply, if you do radical 300 over 1200, you are gonna get 1 over 2. So 1900 over speed 2 is equal to 1 over 2. Now cross multiplication, you're gonna get speed 2 is equal to 2 times 1900, which is 3800. So our answer over here is 3800. Now we move to question number 5. A fixed amount of gas is kept at temperature T. The average speed of its particles is V and their average kinetic energy is E. Okay, so E, we know, is directly proportional to T, average energy, and their average speed is directly proportional to the radical of T. So the average kinetic energy, they told us what? The temperature of the gas is quadrupled. So what's happening is we're multiplying this by 4 and we're multiplying this by 4. That means if you multiply by 4 over here, then you're gonna multiply by 4 over here, since they are directly proportional. So now the average kinetic energy becomes 4 E, okay? They said you can write average speed or velocity, or V, for example. So let's do V is directly proportional to the radical of t. If we multiplied it by 4, because it is inside of the radical, okay, that means that the V, the average speed, is directly proportional to what? What is the radical of 4? The radical of 4 is 2. So it's directly proportional to 2 times the radical of t. So if you multiply the radical t by 2, that means you're also going to multiply the v by 2. So that means the average speed of the gas is now 2v. So very simply, our answer over here is 4e, and our answer over here is 2v. Number 6, the structure of a thermocouple is shown below. Now, a thermocouple is a device by itself, and it is made of many devices. The thermocouple as a device by itself, it measures the change in temperature or the temperature, okay? Now, the wires, let's discuss the wires. In the thermocouple, the 2 wires that come out from the meter, so this wire over here and this wire over here, they are made of the same material. So W and Y equal same material. However, wire Z is a different material. So W and Y, because they both come out of the meter X, which we will discuss later, it's called a galvanometer. Okay. If they both come out of the galvanometer, then they are the same. Okay. However, if it is a single wire by itself, not coming out of the galvanometer, then it is a different material. Now, meter X is called a galvanometer. What about the galvanometer? The galvanometer just tells us if we have a current or not, and in which direction the galvanometer is pointing. This is where the current is flowing. So the galvanometer measures current. Alright, so if we go down, they told us which wires are made of the same material. We said it's wire W and wire Y. And what does meter X measure? It's a galvanometer, so it measures the current. Now, which statements correctly describe a thermocouple? A thermocouple have a low heat capacity, so they can react quickly, so they can detect the change in heat quickly, okay? They have a relatively high precision, that means they're very, very accurate. They have a quick response to temperature changes also, okay? They can measure only high temperatures? No, they have a wide variety of measuring the temperature. They can measure really cold temperatures or really hot temperatures, okay? And do they have a slow response? No, they have a fast response to temperature changes. So the only 2 answers are these 2. Now we proceed to question number 7, a very easy question. The absolute temperature of a gas is 150 degrees Celsius, so 150 plus 273, you are gonna get 423 Kelvin. Remember, from degrees Celsius to Kelvin, you add 273, but from Kelvin, so big temperature, Kelvin, to degrees Celsius, you subtract 273. So here the absolute temperature of a gas is gonna be 150 plus 273, so 423. Now we move on to question number 8. Okay, a fixed amount of gas is kept at a constant temperature. We said constant temperature is Boyle's law. Boyle's law, what is constant? It is the temperature and the mass. Okay, since the temperature and mass are constant, if we apply the formula P1V1 over T1 equals P2V2 over T2, we know that the temperature is constant, so we cross out the temperature, and we get P1V1 equals P2V2. So this is our formula. Another way to say it is that Boyle's law states PV equals constant. Alright, so in Boyle's law, the PV is equal to a constant, the pressure is inversely proportional to the volume, and the volume is inversely proportional to the pressure. If you are going to plot it, okay, the volume to the pressure, if you're plotting volume and pressure, it will look like this, okay? However, if you are plotting a volume and the inverse of the pressure, then it is a straight line passing through the origin. Alright, so you have to pay attention to how you are graphing it. If it's volume and pressure, then it's a downward sloping curve, or like this, okay? But if you're doing a volume and the inverse of the pressure, then it's a straight line passing through the origin, okay? So now, they need the temperature of the gas in Kelvin to the nearest integer. So here we have 25 degrees Celsius. To change it into Kelvin, you are gonna add 273. So 25 plus 273, this is 298 Kelvin. So in Kelvin, the temperature is 298. We said to find the final volume of the gas above, which law will we apply? Because we have a constant temperature, we are going to be applying Boyle's law. You spell Boyle like this, Boyle with an L and then apostrophe S. Now, very simply, to find the final volume of the gas, we apply this rule where P1 V1 over T1 is equal to P2 V2 over T2. Since the temperature is constant, they are gonna cross out. So we get P1 V1 equals P2 V2. You can solve it like this, or you can say that Boyle's law states that the pressure is inversely proportional to the volume, or the volume is inversely proportional to the pressure. So then we get, as a result, PV is equal to constant. And then you can say P1 V1 equals P2 V2. Now, to find the final volume of the gas, we're just going to substitute. We have the initial pressure, which is 1 atmosphere, multiplied by the initial volume, which is 12, okay, is equal to, now, the new pressure, which is 3 atmosphere, multiplied by the new volume. So now, to find the new volume, you're going to divide both sides by 3. You get 1 times 12 over 3 is equal to volume 2. So then, volume 2 is 4 centimeter cube. Okay? Now we proceed to question number 9. We have the initial pressure of a dilute gas and its volume. Okay? They told us for Boyle's gas law. What does Boyle's gas law state? It states that the volume is inversely proportional to the pressure. So that means PV is a constant. But all of this happens if what? If the temperature is constant. Alright? But of course, not only the temperature, but also the mass. So the temperature and the mass must be constant for us to apply this law. So, for Boyle's gas law to be applicable, the temperature and the mass of a gas must remain constant. You can do it like this, or you can say that in Boyle's law, we have what? Two things that we are multiplying together, P and V, because its PV is equal to constant. So you're going to choose everything that includes anything except pressure and volume. This includes pressure, you don't take it. This includes pressure, you don't take it. This one has pressure and volume, you don't take it. So you take the only thing that does not have pressure or volume. Now we move down. They need us to find the volume of the new gas, okay? We know the equation is P1 V1 over T1 is equal to P2 V2 over T2. Since the temperature is constant, we cross it out, then it becomes P1 V1 is equal to P2 V2. So then substituting, we are going to get 8 times 15 is equal to pressure 2 times 30. So now we divide both sides by 30. 8 times 15 divided by 30. We are then going to get that pressure 2 is equal to 4. So that means the new pressure becomes 4 atmospheres. Now we move on to question number 10. Okay, this one is also nice. We have a fixed amount of gas is initially at 27 degrees Celsius. This is temperature initial, and has a volume of 8 centimeter cubed. So this is volume initial. They told us that the pressure is kept constant. If the pressure is kept constant, then we are talking about Charles' law. Charles' law states that the volume is directly proportional to the absolute temperature. Okay, so if you are gonna plot it, it's gonna be volume here, temperature here. It's a straight line passing through the origin. And then the equation becomes V over T is equal to a constant. Okay, now pay attention. Here they told us that the absolute temperature is halved. So that means we cannot use degrees Celsius. Anyways, you cannot use degrees Celsius. You always need to change it to Kelvin. So 27 into Kelvin, you add 273, it becomes 300 Kelvin. Now, they're telling us that the absolute temperature is halved. So temperature 2 is equal to 300 Kelvin divided by 2, which is 150 Kelvin. Okay, so then it becomes volume 1 over temperature 1 is equal to volume 2 over temperature 2. Alright? How did we get it? We got it from the equation P1V1 over T1 is equal to P2V2 over T2. So then what happens is you're going to cancel the pressure since it's constant, and then you get V1 over T1 equals V2 over T2. Substituting, we are going to get then that 8 over 300 is equal to volume 2 over 150. So now, very simply, you can do cross multiplication. So 8 times 150 divided by 300, we are going to get 4. So volume 2 is equal to 4. So here we said we're going to apply Charles' law. You spell Charles like this, apostrophe after the S, and here it is 4 centimeter cubed. Okay, now we move on to question number 11. The initial pressure of a dilute gas is 8 atmosphere, the volume is 12 centimeter cubed, and the temperature is 27 degrees Celsius. For Charles' law to be applicable, the only things that should be constant are the pressure and the mass, okay? Otherwise, the temperature and the volume should not remain constant. So what should be constant? The pressure and the mass. Now, if the volume of the gas is increased to 18 centimeter cubed at a constant pressure, then the new temperature of the gas to the nearest integer is. Okay, we have, first of all, our initial volume, so volume 1 here, and then we have our temperature in degrees Celsius, okay, which is the first one. Then we need to change it into Kelvin. So absolute temperature 1, okay, is gonna be 27 plus 273, so it is 300 Kelvin. Alright, then to find volume 2, it is here given, this is volume 2. We need to find the new temperature. To do that, we're going to apply P1 V1 over T1 is equal to P2 V2 over T2. We have what is constant? We have that the pressure is constant, so we cross out the pressure, and we get this equation. V1 over T1 is equal to V2 over T2. Now substituting it, it becomes 12 over 300 is equal to 18 over the new temperature. Then solving it, you are gonna get that temperature is like temperature 2 is equal to 18 times 300 divided by 12. Okay? And we are gonna get that temperature 2 is 450 Kelvin. But my question is, do they need it in Kelvin? No, they need it in degrees Celsius. So to change it from 450 Kelvin into degrees Celsius, we are gonna subtract 273. So 450 minus 273, it is then 177 degrees Celsius. So our answer over here is 177 degrees Celsius. Now we move on to question number 12. A fixed amount of gas is sealed in a rigid cylinder of volume 20 centimeter cubed. Initially, the gas is at this and 600 millimeters of mercury. It is then heated to 27 degrees Celsius. Okay, looking at it, alright, we are saying that it is a fixed amount of gas is sealed in a rigid cylinder. Rigid cylinder meaning it cannot be compressed, it cannot be expanded, so the volume will remain constant. If the volume remains constant, then we are talking about what? About the pressure law. Pressure law states that pressure is directly proportional to temperature, so then P over T is a constant, and then when you graph it, it is a straight line passing through the origin. Alright, and then our equation is going to be P1 V1 over T1 is equal to P2 V2 over T2. Okay, we're going to cancel the volume because it is constant. Alright, so now we discussed the pressure law. Let us quickly identify what we have. We have the initial temperature, but we need to change it to Kelvin. So you do minus 23 plus 273. And you are going to get 250 Kelvin. This is temperature 1. Then you have pressure 1, which is 600 millimeters of mercury. They told us it is then heated to this. So temperature 2 is then going to be 27 plus 273, which is 300 Kelvin. So we have pressure 1, temperature 2. We know that we found it to be pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Substituting, you are going to get 600 over 250 is equal to pressure 2 that we need to find over 300. So then doing cross multiplication, we get pressure 2 is equal to 600 times 300 divided by 250. So on the calculator, we are going to get 720. So the final pressure, or pressure 2, is 720 millimeters of mercury. And we said that we would be applying the pressure, I forgot to write pressure, okay, pressure law. Okay, now we move on to question number 13. This is nice, okay? Let's read. A fixed amount of gas of volume 20 centimeter cube. They didn't tell us it's an air-rigid container, so we cannot say the volume is constant. All right, so we are going to take this as volume 1. It is initially at 7 degrees Celsius, so this is temperature 1. We need it in Kelvin, so it's 7 plus 273, so 280 Kelvin. And this over here is what this is, pressure 1. The temperature of the gas is raised to 147 degrees Celsius. So temperature 2 in Kelvin is 147 plus 273, so 420 Kelvin. They also told us that the pressure is doubled. So pressure 2 is equal to what? Is equal to 2.5 times 2, which is then 5. They need us to find what? The new volume, so volume 2. So what equation do we apply? We apply P1 V1 over T1 is equal to P2 V2 over T2. So the first pressure is 2.5, okay? 2.5 times the first volume, which is 20, over the first temperature, which is 280. It is equal to what? It's equal to pressure 2, which is 5, times volume 2, which we need to find, over temperature 2, which is 420 Kelvin. So then we do cross multiplication. We are going to get 280 times 5, so 1,400 times volume 2 is equal to 420 times 2.5 times 20 is equal to 21,000. And then you can find volume 2 by doing 21,000 divided by 1,400, and we are then gonna get 15. So very simply, volume 2 is equal to 15 centimeter cubed. Now we move on to question number 14. This is something really nice. Let us explain step by step what each one is. Over here, we have something that is giving heat to the glass. Let me draw it in red so it's more like heat. So it's giving heat to the glass. It is heating the glass. So we say this is heat. Then inside of the glass, there is water. When you add heat to the water, it starts to boil, okay, when it reaches 100 degrees Celsius. So we call this boiling water. Now, when water boils, it will change, and it will change from water to gas. The gas of water, we call it steam, and usually the steam is at 100 degrees Celsius, so it is steam at 100 degrees Celsius. And now, since this over here is steam, then what we calculated over here is what? It is the steam point, which is 100 degrees Celsius. This we use it for a calibrated thermometer, okay? Now, they might ask you a question, why do we have a hole over here? Why is there a second hole in the cork? Very simply, this is so that the steam will not stay in, will not be very compact inside, and it will not exert too much pressure on the walls of the glass, because otherwise the glass might break. And also it is to keep the pressure constant. So why do we have a second hole in the cork? This is to ensure that the pressure is not too strong inside of the glass, okay, so that it will not break, and also to ensure that the atmospheric pressure is the same inside and outside, because water boils at 100 degrees during atmospheric pressure. So water boils at 100 degrees only at 1 atmosphere, which is atmospheric pressure, okay? So if you keep this hole, then the air outside is gonna enter inside, and it's gonna keep the atmospheric pressure 1, so then the water is gonna boil at 100 degrees Celsius. So now we move on to question number 15. Okay, which of the following are hazards of calibrating a mercury thermometer? Very simply, calibrating hazards, just memorize them. They are 3. They are heat, you have toxic substances, and also you have the fragile glassware. So these 3, memorize them. They are the same for all the questions of calibrating hazards. So it is the extreme heat, the toxic mercury, and the fragile glassware, not the toxic steam. Steam is not toxic, it's just really hot. So now we move on to question number 16. The graph below was plotted after the calibration of a mercury in glass thermometer. In order to plot a point 10 centimeters, 0 degrees Celsius, the thermometer was placed in contact with, okay. In order to plot a point at 0 degrees Celsius, you need to put the thermometer in melting ice, because ice melts at 0 degrees Celsius. Okay, so melting ice. Pay attention, don't choose the ice salt. Ice salt is not pure, okay, so it will not melt at 0 degrees Celsius. In order to obtain a plot at 100 degrees Celsius, water boils at 100 degrees Celsius, so you need steam, okay? So you need the steam of boiling water, because this is at 100 degrees Celsius. Now, the length of the mercury in the thermometer is 22 centimeters when in contact with a cup of tea. Okay, so then the temperature of the tea is what? Very simply, we're gonna go to the graph, okay? We're gonna say, okay, this is 0, 2, 6, 2, 4, 6, 8. Then 10, 12, 14, 16, 18, 20, 22. Over here is the 22 in centimeters. It is 60 degrees Celsius. So the temperature of the cup of tea is 60 degrees Celsius. Now the size of 1 degree Celsius on the thermometer in millimeters. This is a very nice question. It requires some math. So what we're going to do is first we're going to find the slope. To find the slope, you're going to take any 2 points. So for example, this one and this one. It will become what? It will be 60 minus 40. So y minus y over x minus x. This is 22 over here, and this is 18. Over 22 minus 18. So 60 minus 40 over 22 minus 18. You are going to get that the slope is 5. Okay? Now, they told us they need the length of 1 degree Celsius. We know that 1 degree Celsius is on the y side, so it's somewhere over here. So instead of using the graph, what we are gonna do, since we found the slope, we're gonna take the y, which is 1, okay, and we are gonna divide it by the slope, which is 5. 1 divided by 5 is 0.2 centimeters, but they need it in millimeters, so you multiply by 10, it becomes 2 millimeters. So over here it is 2 millimeters. We proceed to question number 17. The ice point on a mercury in glass thermometer is at 10 centimeters. The steam point on the same thermometer is at 50 centimeters. Drag and drop the correct answers to complete the following diagram that describes the calibration graph for this thermometer. So, we have the temperature over here and we have the length over here. We need what? This is a calibration graph. So the calibration graph is gonna start at 0 degrees Celsius in temperature and end at 100 degrees Celsius. So definitely the temperature over here is gonna be 0 and the temperature over here is gonna be 100. This one is logic. Now, using even more logic, the distance over here is gonna be 10, or like the length over here is gonna be 10, and the length over here is gonna be 50. So the plotting of the points on the graph was basically logic. Now they need when the thermometer is immersed into liquid of temperature 50 degrees Celsius. So to find 50 degrees Celsius, we're gonna take as 0, 10, 20, 30, 40, 50. So over here, it meets at this point. This is 50 degrees Celsius. It meets at this point, and this length is 10, 15, 20, 25, 30. So the length in centimeters at 50 degrees Celsius is 30 centimeters. Now we move on to question number 18. Okay, on the Celsius scale, the ice point is equal to 0 degrees Celsius. You remember you used to call it freezing point, boiling point. Now change freezing point to ice point and boiling point to steam point. So the ice point is at 0 degrees Celsius and the steam point is 100 degrees Celsius. But remember, I said water only boils at 100 degrees Celsius if it is at atmospheric pressure, which is 1 atmosphere. 1 atmosphere in Pascal is 100,000 Pascal, which if you change it to kilopascal becomes 100 kilopascal. So the ice point is only at 0 degrees Celsius if it is at 1 atmosphere, which is 100 kilopascal. And the steam point is only at 100 degrees Celsius if it is at the atmospheric pressure, which is 1 atmosphere, which is 100 kilopascal. Now we proceed to the final question. We have the liquid in glass thermometer below is to be calibrated using the Celsius scale. 2 fixed points should be located on the thermometer. They need the name of the lower fixed point. The lower fixed point, always in a calibrated thermometer, okay? The lower fixed point is the ice point, which is the melting point, okay? The ice point or the melting point is at 0 degrees Celsius if it is at atmospheric pressure. So here let's consider it is at atmospheric pressure. Now how do you reach the lower fixed point? It is reached by placing the thermometer in melting ice, because ice melts at 0 degrees Celsius. Now the name of the upper fixed point is the steam point or the boiling point. The steam point is reached at 100 degrees Celsius. So to reach the upper fixed point, okay, we have to place the thermometer above boiling water, because water boils at 100 degrees Celsius only at atmospheric pressure. So let's submit, and inshallah we don't have any mistakes, hopefully. And thank God we don't have any mistakes. I hope you guys enjoyed and have a wonderful day.